Hello and welcome to the spring break refresher for stoichiometry and chemistry. I'll be creating a series of videos that will hopefully help you in learning stoichiometry a little bit better. Now in its most basic form, stoichiometry is a way of describing the relationship between reactants, which are things you start out with in a reaction, and products, which are those things that are created by the reactants. The first thing you'll need to know to be able to do well in this stoichiometry chapter is how to balance chemical equations. All right, in this case, I start out with hydrogen and oxygen, and the mixture of them with a little bit of heat creates some water. Some basic skills will be needed in balancing equations. If you're still a little bit shaky on that, that might be the first thing you need to go practice. All right. Now, in stoichiometry, I said it's a comparison between the reactants, which are things that are always on the left side of equation. Those are the things that are reacting together, and they are producing products. All right, this is the same for all chemical equations. We could be reacting some metals with some other type of liquid to create a gas. Whatever the reaction is, doesn't matter. Whatever's on the left side is always the reactant. What's going into the reaction, whatever's coming out the right side, is always the products. It's what's being produced. Now, like I said, stoichiometry is a comparison between not just what goes in and what comes out, but how much of each go in. And we use a few types of measurements to describe how much of those go in. The first one you may be familiar with is mass. And for this course, we will be using grams to measure the amount of the mass. We will also be dealing with moles. 1 mole is a very specific number. 1 mole of a substance is 6.02 times 10 to the 23rd numbers of something. If you have a mole of eggs, you have 6.02 times 10 to the 23rd eggs. If you have a mole of atoms, which is what we may be dealing with here, you'll have 6.02 times 10 to the 23rd of those. Now, into our first problem. Let's take one a little bit more difficult than this. If we take a combustion reaction, such as a very simple one, methane, CH4, react it with a little bit of oxygen, it will create the same thing all combustion reactions do, carbon dioxide and water. This is very similar to what happens in your car as you drive around and the carbon dioxide is coming out of your tailpipe. It also creates a little bit of water. Okay. Now, as I said, balancing these equations is a skill that's absolutely necessary in this chapter, because right now a very important law in chemistry is being broken here, and that's the law of conservation of matter. On the right side, you can see that we have 4 hydrogens, but on the right side we only have 2. If we left our equation like this, matter would just be disappearing, which is a law that we cannot break in chemistry. Here's a quick example of me balancing this equation. I'll do it fairly quick. If you get lost, you can pause, go back and watch this again. There's 1 and 1 carbon. There are 2 and 2, 3 oxygens. There are 4 and 2 hydrogens. We need these numbers to be the same on both sides. First thing I'll do is the hydrogens. This is a 2, believe it or not. I'll put a 2 over here. I now have 4 hydrogen. And I now have 2 oxygen and another 2 oxygen. Now all that's unbalanced is the oxygen. If I put a 2 over here, I now have 4 oxygen on this side, 4 oxygen on this side, and everything is balanced. Alright, let me take this and move it out of our way. So now we can work here. Today's video, we're going to be focusing on moles. We're not going to get into mass yet. We're only going to compare the number of moles of these compounds that go into the reaction, the reactants, and how many moles come out. When we're comparing the amount of moles of one substance to another, such as how many moles of CH4 go into the reaction compared to how many moles of water come out, right, we use something called the mole ratio. Oh, wrong brush. Mole ratio. And this is a comparison between the amount of moles of substances. Right? For instance, in this equation, even though we don't write it, there is a 1 and a 1 in front of these compounds. The coefficients, these numbers out in front, they represent CIENTS. The coefficients represent the number of moles of that substance. So the way this reads is 1 mole of CH4 reacts with 2 moles of oxygen 2 to yield or produce 1 mole of carbon dioxide plus 2 moles of H2O. 1 mole of carbon dioxide and 2 moles of water are produced or created. Okay, now how do we use that? The first thing we can do is we can set up smaller scale ratios. We can set up, instead of talking about the entire thing at once, we can focus in on just 1 or 2 of them. For instance, I see if I start out with 1 mole of CH4, it's also known as methane, that in that reaction, whatever's going to happen to oxygen, it will produce 1 mole of carbon dioxide. So instead of comparing the whole thing at once, we can break it apart and just view individual pieces at a time. I'm not concerned with oxygen or water at the second. I only want to concentrate on methane, CH4, and the carbon dioxide. And we see if we do that, that for every 1 of CH4, we have 1 carbon dioxide. 1 and 1. Now, why is this useful for us? Well, let's say instead of starting out with 1 mole of CH4, I start out with 7.5 moles of CH4. Well, how can I find out how much carbon dioxide would be created in that equation? Well, this one is easy for us all to see. We can see that due to this relationship here, there is exactly the same amount of methane, CH4, going in as there is carbon dioxide coming out. That's what the 1 and 1 represent. They're the same. So if 7.5 moles go in, then 7.5 moles of CO2 come out. Now, if it was always in a 1-to-1 ratio or even a 2-to-2 ratio where the same amount that came in was the same amount that came out, we wouldn't need all this math that we deal with in stoichiometry. But if we take a second example up here, if we take for every 1 mole of CH4, 1 mole of CH4, that we actually produce 2 moles of water. We can say this now, 2 moles of H2O. Now, while this will still be easy for a lot of people to see, for every 1 mole of CH4, there are 2 moles of H2O produced. However much CH4 you have, twice as much water is going to be produced. So in the same example up here, if we start with 7.5 moles of CH4, then twice as much water is going to be produced. 7.5 moles of carbon dioxide. However, there will be 15 moles of H2O produced. Okay. Now, I'm going to cut this video short here. This is kind of an introduction one. The next video that I create will involve us dealing with ones that we can't just look at with our eye. Some of these problems you have to use mathematical equations to deal with, simply because they are too hard to discern just by looking at. As you've probably found by finding this video, all of my videos are going to have a certain format with naming. This was Stoichiometry Chemistry Video 1A. The next video you should view will be Stoichiometry Chemistry or Chemistry Stoichiometry B, 1B. Right? And as each day comes along, the number of the videos will change. Tomorrow's videos will be Stoichiometry Chemistry 2A and 2B. Alright, thank you. I'll see you in the next video.